Welcome to my channel, Chemical Kinetics. 41st question. If a reaction A plus B gives rise to C is exothermic to the extent of 30 kilojoules per mole, and the forward reaction has an activation energy 70 kilojoules per mole, the activation energy for the reverse reaction is. Here the given options are.
According to the question, the enthalpy of the reaction delta H is equals to 30 kilojoules per mole. In the question, they gave that it's an exothermic reaction, so we have to take it as a negative. Activation energy of the forward reaction is given as 70 kilojoules per mole, and we have to find out the activation energy of backward reaction. For this, we have a formula. Delta H is equals to activation energy of forward reaction minus activation energy of backward reaction. By substituting these values, we will have activation energy of backward reaction. That is, delta H minus 30 kilojoules per mole. Activation energy of forward reaction is 70 kilojoules per mole minus activation energy of backward reaction. So activation energy of backward reaction is equals to 70 plus 30. That is 100 kilojoules per mole. So the option is 4. We can solve this question by using graphical method. Let's take the energy diagram. In the question, they gave that it's an exothermic reaction. In exothermic reaction, the energy of the reactants should be greater than the energy of products. In exothermic reaction, the energy of the reactants should be greater than energy of products. According to the question, the difference between these two is 30 kilojoules. 30 kilojoules. While forming products, reactants has to gain some energy to reach threshold energy. Threshold energy. In order to form products, it has to gain some energy. That energy is nothing but activation energy of forward reaction. That is 70 kilojoules per mole. But we want to know the value of activation energy of backward reaction, that is products to reactants. So if you want to get the reactants back, the products has to gain this much of energy. How much of energy? From here to here 30 kilojoules, from here to here 70, total of 170 plus 30, 100 kilojoules of energy, 100 kilojoules of energy to reach its threshold energy so that it can form reactants back. So this is the activation energy of backward reaction. Thank you.